Today is another palindromic date, right? In fact, there's like 10 days in a row of palindromic dates. Did we talk about this yesterday? Today is 3/23/23. And it's do you guys know what palindromes are, right? Yeah, and it's neat. Like even tomorrow will be a palindrome, and then Saturday will be a palindrome. They're all going to be palindromes because this number right here just doesn't matter, right? Do you see, isn't that neat? Did we already point this out yesterday? Isn't that cool? So like it started on so is that not interesting to you? I think it's really interesting. So like it started on the 20th, 3/20/23. Look, was 3/20/23. 3/20/23. And then and the nature of this is that, we're in the third month and the days that start with 2. So it doesn't matter what number you put here, and we're in the year 23. So you just kind of can't escape the fact that you're going to go 3/2/3/2. So like today is the fourth palindromic date in a row, 3/2/3/2/3. I think it's neat. Whatever. Anyways, today is the 23rd. And what we're doing is solving exponential equations. If this were if we did this before we did compound interest, this would be a struggle bussy kind of lesson. Like there'd be a lot of what's going on. But I really do think that with what we've already done, that you're just gonna be like, yeah, I got this. So we're gonna not have any words in these problems today or tomorrow, or I mean Monday. This is just meat and potatoes, X's and numbers and stuff. So I've written 6 examples. If you feel like you'd like some more, I would, of course, be more than happy to pop out some more. So first one I wrote for you is 4 to the power of X equals 120. Do you smell like burning breakfast? You getting that? Anyone else getting that? Pancakes? Burnt pancakes? This is a really wicked hard situation. If you think about the complexity of this, like we should probably know that the answer is between 3 and 4, because what's 4 to the power of 3? 64. What's 4 to the power of 4? 256. And so if we know that we're trying to make 4 to some power equal 128.9, then we know it has to be 3 point something, because like 3 is too small and 4 is too big. But so you could Prices Right this thing. If you ever watch Prices Right, like where they guess low, and then like Bob Barker would tell them like you're too low, and then they go high. And basically what happens is if you figure out you're too low, you guess higher. And then if you guess too high, you guess in between. So you could Prices Right this thing. And it would take you probably 5 or 10 minutes to figure out. You could probably get a few decimal places of accuracy after a while, right? Just guessing and checking. We're not going to go that road. How do you think we can solve this equation? No. I mean, you could, if you're guessing and checking, I could just guess. I could just do like 4 to the power of 3.25. I'm like, oh, that's 90.5. And then I could go like, oh, 4 to the power of 3.58. And I go, oh, that's too big. And so, yeah, I mean, you could just keep typing numbers into your calculator until you get what? Until you get 128.9. How do we solve an equation like this? I don't want to guess. I wish there was some cool way to like get that X to come down. That's what we need, is like we should figure that out. Yeah, you don't want to root, we want to log. If I'm any good at this, you remember that when we have a variable that's hiding in an exponent, the only way to bring him down so we can work with him is to log. So we're going to take a log of both sides. And it doesn't matter what log, natural log or log. In this case, it would make no difference. So let's go ahead and take the log of both sides. So we have log of 4 to the X equals log of 128.9. And the fact that we took a log enables us to do something really rad. And what is that something? Yeah, take your X down and bring it in front. So before we divide anything, let's take a look at what this equation looks like. So I'm going to take this X. I'm allowed to do this now. I mean, it's like 90% of why we even teach you logarithms is because I can now take this x and bring it down into a level playing field. So I'm going to have x times the log of 4 is equal to the log of 128.9. And at this point, we should be ready to green light into the calculator, right? How would we get x by itself? So let's all together with our, assume you have your calculator. Let's all type that in together. So we're going to type in log of 128.9. Make sure you close those parentheses and then hit divided by log of 4. Make sure you close those parentheses. And we're always, for the next several days, going to be rounding to 4 decimal places. We call that the nearest 10,000th. So we want a little more accuracy going down this road. So what is that going to be rounded to 4 decimal places? Good job, you guys. So we're going to say x is approximately equal to, notice I used the squiggly equal sign because this ain't perfect, right? You don't have to. I don't care. But x is around 3.5051. And that's what we started class with today, was talking about that. There would have been a 0 there, but to the right of his wall would have been a 5, which bumps him up to a 1. Any questions on that? Okay. Let's look at another situation similar, but a little bit different. Let's say I gave you 10 to the power of 4x is equal to 3,484,526. Again, I'm willing to bet that a very dedicated student who had never heard of logarithms before could start guessing numbers and eventually start to figure out what x has to kind of sort of be, right? Getting it to 4 places, that's a tall order. That's a big ask. But you could. I bet if I gave you like an hour and a calculator and said, find me the answer to 4 places, you could just start narrowing in on it. It's not what we're going to do. So what are we going to do? Good job. Now, I didn't choose this example because I wanted to do the exact same problem with you again. I chose this problem because I wanted there to be a moment where you look at what I just wrote on the TV and you ask a question like, hey, I think you messed up, right? Why? Good. So the point of this example, as I wrote it and thought of you, was that when the base of the power is 10, when you use a log, remember that the log that we commonly use is, well, it's called a common log. It's a base 10. And we know from a prior, like 2 quizzes ago, that what would have gone next to the 4x would have been a log of 10. But we learned 2 quizzes ago that log of 10 is redundant, right? It equals 1. So we have a little bit of a benefit in certain problems, and you'll find a few of them sprinkled throughout today's worksheet that if you see a 10 to the whatever, then you're like, jackpot, that's going to save me a little bit of annoying stuff in my calculator because I don't need to write the log of 10. Like, I'm not going to put that there. So I'm going to move my 4x back. So the math is a little bit simpler to put in our calculator. What would I type in this time? Yep. So we need log of 3484526 close parentheses divided by 4. I don't even have to acknowledge the log on the left side because, again, he kind of offed himself because he was a log of 10. And that's just a throwaway. So this time my rounded answer is going to be x is approximately equal to 1.6355. No rounding necessary on this one because after our 4th place is a 3, and that has no impact on the 5. So, right, the last of our warm-up problems, you might have guessed where this is headed. If you're kind of in the moment, you probably know what I'm up to. Let's say we did e to the power of 4x minus 1 equals 526,450.8. If you don't appreciate the power of logarithms, you're just not paying attention because the complexity of this situation, trying to figure out what x is, I mean, it would take you, I'm serious, I think it would take hours manually to figure this answer out to 4 decimal places. What a pain. So what are we going to do? We're going to natural log both sides. And we've seen this benefit before. Having just done the compound interest quiz, you know that when we're going to log a PERT equation, we're always going to use a natural log to get that little bit of kickback, that bonus. So I'm going to natural log both sides. And my left side is going to say 4x minus 1. And my right side is going to say natural log of 526,450.8. And I'd answer the same question again, right? Did I mess up? No. What would have been next to my 4x minus 1? A natural log of e, which in the same light as the log of 10 is 1, pointless. So let's talk about the algebra that's required to solve this equation now. It's really just a little algebra 1-y sort of situation here. How would I go about getting x by himself? And then what? Add 1. And then divide by 4. And when and how we choose to hit equals is going to be of paramount importance. So like if I just go about my business and I go, okay, natural log of 526,450.8, and then I hit +1, and then I hit divided by 4, I'm going to miss it. Why? Because I didn't equal it after adding 1. And remember, your calculator is going to, if you don't tell it otherwise, your calculator is going to get all up in your business and it's going to do 1 divided by 4. It just will, because that's what it's programmed to do. So we have to get in the way. And after we do this part, we have to hit enter or equals and then times 4 divided by 4. So let's work that one out real quick, and then we'll get on to the more complex situation. So natural log, make sure you use natural log, 526,450.8, close parentheses, +1, enter, divided by 4. What'd you guys get? Nice job. Good rounding, by the way. So x is approximately equal to 3.5435. Round up to a 5 because next to the 4 is a 7. So those are our little warm-up-y problems. Any questions about just generally what to do? Okay. How about this? So what I'm going to do now with these next examples is just start adding in a little bit more spice each time until we get to the point where we're like, got it, you can't stump me anymore. So a little bit of basic algebra here. What do we have to do? Right. And if you even say log both sides, you're done. You're missing it 100% of the time. We're not ready to apply the logarithm until we've gotten the power by itself. And this thing that I'm putting a yellow box around is called a power. And the log won't apply itself correctly unless that thing is alone. So we're going to do -6 on both sides. And we're going to get 9 to the power of x equals 2,409. And then from here, it's probably pretty much just kind of like ho-hum, right? What are we going to do now? Yeah. So on the left side, we're going to have x times the log of 9. And on the right side, we're going to have the log of 2,409. And you should totally be okay with the fact that when I went here, look at the green arrow, that I did 2 things at once. Yes, I logged, but I also dropped my power. Like, why not, right? And you won't even be showing you this much work 20 minutes from now. Like you'll be even skipping some more steps than that. So um, again, check our rounding because that's clearly something we need to focus on. So let's do log of 2,409 divided by log of 9. I got 3.5440. Sound good? All right. All right, so I'm going to sprinkle now a little bit of extra complexity into the mix here. So here we go. Let's do 14 minus 3 to the power of 2x minus 1. Um, I didn't mean to do that. Erase. I forgot to put something here. My bad. 14 minus 3 times 2 to the power of 2x minus 1 is equal to negative 28. Right. And again, honestly, what I found in previous years with this little mini chapter that we do is that the issue isn't really that my students don't know how to use logs and stuff. It's just the intro, and as your Algebra 1 teacher, I guess I got to own that. But like the step one has nothing to do with logs and powers. Step one is just to basically say, okay, this is algebra. I need to get that gold box by itself. And what is step one? I know I heard Alyssa say it. What every one of you should know what has to go first. Yes. If you even think about the three, then I'm no good and we're together, we're hurting, we're failing each other. The three can wait. I've got to subtract the 14 first from both sides. And that's going to lead me to negative 3 times 2 to the power of 2x minus 1. And if I subtract 14 from the other side, what do I get? Good job. It's just like solving equations always has been. Do your plus or minus away first. Do your times or divide away second. Right? This doesn't change. Now what will we do to both sides? Don't add 3. You divide. Remember, that is not a minus 3 that we can move by adding him. He's a negative 3 that's multiplied by something. And the only way to detach a multiplier is through division. So I'm going to divide both sides by negative 3. And I can show that step if you would like. So I'm going to put divided by negative 3 and divided by negative 3. Cancel those out. And now I'm at the log ready step. So I have 2 to the power of 2x minus 1 equals positive 14. Are we okay to hear? That's all kind of like the intro part, like the cleanup part. And now it's time to actually solve the equation. How are we going to get that 2x minus 1 to come down? We're going to log. And no benefit to a log or a natural log. So I'm just always going to go with just a common log. If you love natural logs, use a natural log. Just know that there's no benefit to either one. So when I bring my 2x minus 1 down, it's going to look like this. And I'm going to write this incorrectly very much on purpose. And if you're still listening, you get to learn something really important about why that is catastrophically incorrect. Do you know what it is? I don't think I did anything illegal. I think I logged both sides, and then I brought the 2x minus 1 down into the front. So why is this so terrible? Anybody see it? It's here, and I'm going to write this in green for you. And the fact that you're all silently sitting here right now means this is a great learning moment. So here we go. You'll never miss this again, ever. You need to put that in parentheses. It is a quantity. It is an item that travels as an item. The item's name is not negative 1 being multiplied by the log. It's not 2x. It is an item named 2x minus 1, and he travels as a thing. And the parentheses are what keep us remembering that he is a package deal. Got it? Don't ever forget that again. Now what? Perfect. I used to teach this a different way, and then I was like, "What are you doing? Like, what? Don't be stupid." I used to have my students distribute the log, and then I realized that's just dumb. Wish I could go back and reteach those couple years. We need to divide, like Alyssa said, we need to divide that log of 2 away. Basically, the 2x minus 1 is not free to move about the cabin right now. They're stuck in there, and I can't do anything with them. But if I could find a way to get rid of the parentheses, which I can if I do this. If you remove the need for parentheses, you then have earned the right to remove the parentheses. And the only reason they're there is because they're keeping that package deal multiplied by the log of 2. But if I can destroy the log of 2 like this, I can now look at the 2x minus 1 and say, oh, you're free. And then 2x minus 1 will equal the answer to that math problem that I'm pointing to with an arrow. Now, from here, let's just let it flow, let it ride, let it play itself out. Think of the algebra now. You've got 2x minus 1 equals a weird decimal thing. It's undoubtedly a weird decimal thing. But I don't want to write it down. How's the algebra going to go from here? How would I get x by itself? Add 1, divide by 2. So using our calculators, what we're going to type in is just a series of events. We're going to type in, actually, here it goes. We're going to do log parentheses 14 close divided by log parentheses 2 close. And then the algebra kicks in. All of our years of practice, we're going to hit +1, and then we're going to hit enter. Right there. And you're going to get some decimal that you're still not interested in. And then with that decimal on your screen, what are you going to do? Divide by 2. Then you're going to take your previous answer, just hit divided by 2, and you shall get the solution. Which I don't know what it is, but I'll catch up to you here. So log of 14 divided by log of 2 plus 1, enter. Divided by 2. You all should have got 2.4037. Correct, Amundo? All right, let's jump up to perhaps the highest level of complexity, and then you should be free to work for a little while, not a long while, but a little while. So, and if you feel like these examples have not satisfactorily scratched your itch for knowledge, then we'll conjure up some more. All right. -3 times 10 to the power of negative x plus 4 minus 6 equals -102. I realize I do a lot of things in my notes that a lot of students don't do, and I'm okay with that, but I'm just going to continue to remind you that this thing is your objective. That yellow thing is just get it by itself, get it by itself. So again, it comes back to our fundamentals, our old years ago fundamentals. What would we have to remove from the situation first? The 6, because he's a detached term. He's not a stick-on divide or multiply away guy. He's a detached move him away. So we're going to add 6 to both sides, which is going to result in -3 times 10 to the power of negative x plus 4 equals, what is -102 plus 6? -96. And now what do we have to do? Divide by -3. Do not even try to log until you've isolated the thing I keep drawing my yellow boxes around. That thing is called the power, and it must be gotten alone. If we divide both sides by -3, we wind up with 10 to the power of negative x plus 4 is equal to +32. And then it's game on. This is all just the prep work, and now it's game on. What are we going to do? And so let me ask you this. If I log both sides, what would my next line say? Well played, Bryn. Well played. Where the heck did the log go on the left side? It's a goner. It's a dead logger. Log of 10 is pointless, right? So again, watch for those benefit problems with the e's and the 10s, because while it's not a big deal, it's nice to be able to save a little bit of extra work. So from here, what would be the steps that we'd follow? Sure, that's a good way to say that. Yeah. So we're gonna, if you want to do it all in your calculator, which I might, I would do log of 32 first, of course, and then the algebra gods say, thou shalt subtract 4, and then of course, of great importance, thou shalt at that point hit enter. Remember, anytime after you've done a plus or minus, hit enter, because man, whatever you do next is going to get in the way. And then at this point, like Alyssa said, you can just look at your screen and literally just change the sign. But if that freaks you out, do bear in mind that you still don't have x by itself. You've got that negative. So at this point, if you wanted to on your screen, you could hit like answer divided by -1. Let me have a gander and I'll let you know. I got 2.4949. Is that what you said? Yeah. And again, the rounding of it, remember, is that the fourth decimal place should be an 8. And after that, if you draw a wall, after the wall is a 5, and the 5 just affects the 8 up to a 9, game over. So 2.4949. Do you guys have any questions about how to solve an exponential equation? What is step 1? Nope. Get the power by itself, right? You do whatever you have to do. Divide something if you have to. Multiply something if you have to. Add something. Subtract. I don't care. You do whatever you have to do to get the base to the exponent powery thing by itself. Then you log and go tinkering around and solve it out. So that's as that, as they say. You mean like in process? Yeah. It's very similar, sure. I just came up with this one because there's a negative on the X, and I figured if I didn't go over it, someone would be like, hey, what do I do when there's a negative on the X? So I just call that running interference. Medical industry would call that like preemptive medication. You know what I mean? Whenever you get a negative on the X, you should have somebody put the negative. Yes. You can divide it by -1. You can multiply it by -1. You can just change the sign. You can, quote, put the negative on the other side. You could do a little turkey dance and then spin around in circles and sing Dixie. I don't care. But yeah, you can do it a million different ways.